Good morning, students. Today we are going to learn about conductivity of coordination compounds. First of all, what is the meaning of coordination compounds? Coordination compounds means the central metal atom coordinated with the different molecules. Such type of compounds are known as coordination compounds. Okay, these coordination compounds are observed. So many types of coordination compounds are there. The types are observed. Some of the compounds are exhibits positive charged character. The type of compounds are known as positively charged coordination compounds. Some of the compounds are exhibits net charge is a negative. That type of compounds are known as negatively charged coordination compounds. Some of the compounds are observed. The net charge is zero. That type of compounds are known as neutral charged coordination compounds. These are the different types of coordination compounds on the basis of net charge of the given coordination compound. But these coordination compounds are observed. These are exhibits different types of conductivity values. For example, platinum related coordination compounds are taken. This is one coordination compound, and this coordination compound is slightly changed. So both are similar, but the position of ligands are differ. So that is the difference in between these two coordination compounds and another coordination compounds. Similarly, these are the same molecular formula, but the ligand positions are changed. Okay, so these compounds are observed. This is a first coordination compound. So these NH3 molecules are shifted to outside of the coordination sphere. The NH3 molecules are shifted to outside of the coordination sphere. Okay. So the first coordination compound is observed. Totally these are 5 coordination compounds. These 5 coordination compounds molecular formulas are similar, but only changes the position of ligand. So the ligands are shifted from inside of the coordination sphere to outside of the coordination sphere. So the first example is observed clearly. It is shifted, it is dissociated into two types of ions. So in this coordination sphere, PTNH36 means a platinum coordinated with 6 ligands. the charge is plus 4 and the chloride ions are shifted to 4Cl minus ions. Okay, so these are the decomposed ions. So this is 1 ion, this is 4 ions. Totally 5 ions are there. 5 ions are present in it. Means the I value is equal to 5. I value is equal to 5. And next one, the second example is observed. Second example is clearly observed. This molecule, one chlorine atom is shifted to inside of the coordination sphere. One chlorine atom is shifted from outside to inside of the coordination sphere. So only the position of ligand is differ. The position of ligand is differ after this complex is dissociated. This complex is dissociated. Platinum bind with 5 ammonia molecules and 1 chlorine atom. Generally, platinum, this is exhibits plus 4 oxidation state. 1 chlorine atom is shifted from outside to inside of the coordination sphere. It is satisfied plus 1 means it is neutralized plus 1. Plus 4 minus 1 is equal to plus 3. And next one, this is a plus 3 charge. And next one, another ions are clearly observed. 3Cl minus ions are dissociated. So totally this is 1 ion and this is 3 chloride ions. The decomposed ions are observed. Totally 4 ions. This is one coordination sphere ion and another one is chloride ions. Totally 1 plus 3, 4 ions are decomposed. 4 ions. Then the I value is equal to 4. I value is equal to 4. And next one, the third coordination sphere is clearly observed. 2 chlorine atoms are shifted from outside of the coordination sphere to inside of the coordination sphere. Okay, this is the difference. So this coordination compound is dissociated. Platinum coordinated with 4 ammonia ligands and 2 chlorine atoms. The net charge is equal to 2. Platinum plus 4, Cl, 2Cl minus 2 plus 4 minus 2. The net charge is equal to plus 2. And outside of the coordination sphere, these are the neutral ligands. NH3 is a neutral ligands. NH3 are neutral. The outside of the coordination sphere, 2 chloride ions are present in it. And then these are the dissociated into 2 chloride ions. Finally, the decomposed ions are observed. The decomposed ions are observed. Totally 3 ions are there. 3 ions are present in it. Then the I value is equal to 3. Then the I value is equal to 3. And next example is taken. Next example, platinum coordinated with 3 ammonia ligands and 3 chloride ions. 3 chloride ions means 3 chloride ions are shifted from outside of the coordination sphere to inside of the coordination sphere. Okay, 3 chloride ions are shifted from outside of the coordination sphere to inside of the coordination sphere. So then the resulting dissociated ions are absorbed. Platinum coordinated with 3 ammonia ligands and 4 chloride ions sorry, and 3 chloride ions and another chloride ion is converted to chloride ion. Totally the number of ions are, this is one ion and this is another ion. Totally 2 ions are present in it. Totally 2 ions are present in it. Then the I value is equal to 2. I value is equal to 2. And last coordination compound. This compound is clearly observed. Platinum coordinated with ammonia molecules and chlorine atoms, but 4 chlorine atoms are shifted from outside of the coordination sphere to inside of the coordination sphere. These compound dissociated to produce different ions. That ions are, first one, platinum coordinated with 2 ammonia molecules and 4 chlorine atoms. The net charge is equal to 0, and the remaining ammonia molecules, there is no ions. 0 ions means no ions are produced. Only the neutral coordination sphere is there. Finally, so 0 ions finally means it's 0 ions are produced. 0 ions means only one neutral charged molecule is there. One neutral molecule is there. Finally, 0 ions are one neutral complex. One neutral complex is there. Neutral complex is there. 0 ions, one neutral complex is produced. Okay, these are the decomposition process of coordination compounds. In these 5 coordination compound, which one is exhibits more conducting value? Which one is exhibits more conducting value? Okay, today our aim is to identify decreasing order of conducting values of this coordination compound. That is our aim. Today our aim is to identify the decreasing order of conducting values of these coordination compounds. Okay. The conducting value of coordination compound is depending upon I value. Okay. The conductivity value of coordination compounds is directly proportional to I. So, conductivity of coordination compounds conductivity of coordination compounds is directly proportional to I value. Is directly proportional to I value. I is indicated as 1/2 factor, means it is expressed the number of dissociated ions. The I value is expressed the number of dissociated ions. It is expressed letter I. I is indicates the dissociated number of ions for the given coordination compound. Okay, these 5 coordination compounds are observed. These are exhibits different I values. I value is directly proportional to conductivity of coordination compounds. So in these 5 coordination compound, I value is 5. The first coordination compound means decreasing order of conductivity of coordination compounds. Coordination compounds. First one, the first coordination compound, I value is 5. So more number of ions are there. That point is based on the first coordination compound is exhibits more conducting value. The first coordination compound is exhibits more conducting value. And the second coordination compound, I value is 4, means 4 ions are present in it. That is next one. And next one is third, 3 ions are present in it. And next one, 2 ions are present, I is equal to fourth one. And the next one, 0 are a neutral complex, that is the fifth one. This is the decreasing order of the conducting values of coordination compounds. Decreasing order of conducting values. Next, Werner's theory of coordination compounds. So, Werner's proposed some points on the basis of coordination compounds. Werner's announced primary valency and secondary valency of the coordination compounds. So, the points are known as Werner's theory. So, first I am going to discuss Werner's theory of coordination compounds. Werner's theory of coordination compounds. First one of the complex is taken K4 Fe CN6. K4 Fe CN6. This is one of the coordination compound. So this coordination compound is observed. It is hexacyano or potassium hexacyanoferrate 2. That is a IUPAC name of coordination compound. In this compound contains 2 types of valency. One of the valency is primary valency. One of the valency is primary valency. One of the valency is primary valency. The primary valency is expressed only opposite charged ions for the given coordination compound. For example, this complex is dissociated. This complex is dissociated. It is dissociated into 2 types of ions. 4 K plus ions means 4 potassium ions and FeCN6 minus 4. So the primary valency is expressed the opposite charged ions, means it indicated the number of opposite charged ions. The above complex primary valency is equal to 4. Primary valency is equal to 4. The above complex primary valency is equal to 4. Why? It indicates only the opposite charged ions for the given coordination compound. So, in this coordination compound, so in this coordination sphere, this sphere is exhibits minus 4 state, oxidation state. The minus 4 interact with another 4 positive charged ions. Finally, that is the opposite charged ions. So this coordination sphere interact with 4 positively charged ions. This coordination sphere having -4 oxidation state. This coordination sphere interact with another 4 positive charged ions. The number of opposite charged ions are expressed primary valency. This is known as oxidation state. Oxidation state. Oxidation state. Oxidation state of the central metal atom. Okay, and next one. So the primary valency is expressed dotted lines for the given coordination compounds. The primary valency is expressed dotted lines. For example, FeCN6 means 6 type of ligands. These are the 6 type of ligands are coordinated with central metal atom iron. Okay, this is FeCN6 and 4 potassium ions are coordinated and 4 potassium ions are coordinated. Okay, in this complex, these positive charged ions are indicated or expressed by dotted lines. Expressed by dotted lines. That is known as primary valency. That is known as primary valency. And next one, I am going to discuss about secondary valency. So next one, this theory is explain the secondary valency of the coordination compounds. Secondary valency. Secondary valency of the coordination compounds. Secondary valency of the coordination compound. This term is expressed both opposite charged ions and neutral molecules. So in this coordination compound like K4, FeCN6, these coordination compounds, for example, another coordination compound is taken like CO, NH3, 6, Cl3. This is the second coordination compound. This coordination compound primary valency is 3 due to this is shifted, this is dissociated into CO, NH3, 6 plus 3 and 3 Cl minus ions. The opposite charge is 3. That point is based on primary valency is 3. In this coordination compound, structure is clearly observed. This coordination compound, central metal atom, cobalt, coordinated with 6 ammonia ligands. Ammonia is neutral ligand. Ammonia, water and carbon monoxide means carbonyl. These 3 molecules are neutral ligands. And in this complex, it is bind with associated with 3 chloride ions, means it is expressed as primary valency. The dotted lines are indicated as primary valency. In this point, the totally 3 dotted lines are there. So that point is based on primary valency is 3. And next one, the secondary valency is expressed. It is satisfied both like opposite charged ions and neutral molecules. So the opposite charged ions CO plus 3 minus 3 both are neutral and 6 ligands are coordinated with central metal atom. That point is based on, so the secondary valency in this coordination compound is 6. Secondary secondary valency in this coordination compound is 6. Secondary valency in this coordination compound is 6. Means CO is exhibits +3 oxidation state. The +3 is satisfied with the 3 opposite charged ions. So finally it is neutral, and then the remaining neutral ligands are coordinated with central metal atom. That point is based on the secondary valency is denoted as coordination number. It is denoted as coordination number. The secondary valency is denoted as coordination number. Okay. So these are the main postulates of Werner's theory of coordination compounds. Next, I am going to discuss some drawbacks of coordination compounds. Some drawbacks of Werner's theory of coordination compounds. Some drawbacks of Werner's theory of coordination compounds. Drawbacks of Werner's theory of coordination compounds. The first drawback is this theory do not explain the stability of the coordination compound. It is do not explain the stability of the coordination compound. This theory do not explain the stability of the coordination compound. Do not explain the stability of coordination compound. And second one, this theory do not explain the color property of the coordination compounds. This theory do not explain the color property of the coordination compound. First one is, this is do not explain the stability of the coordination compound, and this is do not explain the color property of the coordination compound. And third one is, this is do not explain electron configuration of the central metal atom for the given coordination compound. Electron configuration for central metal atom. Central metal atom for the given coordination compound. After some time, the stability is explained. The stability of the coordination compound is explained on the basis of the study of metal carbonyl compounds. The study of metal carbonyl compounds. And the color property of the coordination compound is explained crystal field theory. The electron configuration for central metal atom for the given coordination metal atom, the concept is explained valency bond theory of coordination compound. And further, valency bond theory, crystal field theory, metal carbonyl, that concepts are explained the stability of the coordination compounds, color property of the coordination compounds, electron configuration for central metal atom in different coordination compounds. These are explained.